All right, so comparing data sets using measures of spread. So measures of spread, there's two ways to measure how spread out the data will be. First is range. So what is range again? We already learned about it.
The highest number minus
the highest number minus the lowest. Standard deviation tells you how far each number is from the mean. So the standard deviation is the average of how far all of the data are away from the mean. Okay, so this tells you how to find measures of spread. Here, the metabolic rate is the rate at which the body consumes energy, measured in calories per 24 hours. During a study on diet and exercise, metabolic rate for two different groups of men were observed, which has higher variation. So we're looking for higher variation. First, let's go through and let's see what the range tells us. So we have to be careful because maybe the range may not be right. Because imagine if like you had, I don't know, 8 people had the same metabolic rate and the 9th person had one that was way, way higher. Well, that would like screw up the range. Right. So, because most of them are around the same. So we have to be careful when we use range. We got to be cognizant of the fact that like maybe there's an outlier. But if I want to find the range, I think it was Shania Oren said we do the highest minus the lowest. So let's look for the highest number in group 1, highest number in group 2. Go ahead and look for them.
Highest number would be 1744. No, 1745. 1764. Oh. Sorry. No, 64.
Okay.
No, 64.
So, let's see. So we're looking for the highest and the lowest values.
1723 for the group 2.
Let's see. Yep.
And then
1496. Okay. So if I take these and subtract, I see the range for the left side is 335. Exactly. The highest minus the lowest, 1723 minus 1476. This is going to be 247. Okay. So we think that the left side probably will have the higher, but a better measure of variation and spread is our standard deviation. So I'm going to go through once again and show you how to do this. So I'll go to my calculator. Let me close out of this.
How do you erase this?
So you can do like doc, and then you can do, oh my god, what the heck? You can just do close. Yeah, and just gonna have a new one. File. Do you want to save it? No. Cool. So I go to add list and spreadsheet. If that's not okay. Or you could click home, scroll over to where it has this green thing in the middle, and click spreadsheet and list. So it's very important to list everything in one column. So what I'm going to do is I'm going to do group 1, and I want you guys to do group 2. All right, so let's find the standard deviation.
Please rewrite all of the numbers in the whole thing. Yeah.
So there's what, 4 by 5, so 20 numbers. There's 20 numbers. Imagine doing that by hand. That would suck.
4 by 5?
No, you want everything in a single column.
So we're doing group 2.
You guys are doing group 2, all of the numbers in group 2, but you have to do it in a single column.
Does it matter which order you go in?
Nope.
Wait. Sorry, I know you said this last time.
It's fine. 17, 31. What's wrong?
We're doing every single number
in group 2. And I see you have a 4 by 5 matrix for group 2, but you want to list them all in one column. It has to be in one column. Okay. I want to be very specific because earlier my other class did it in not one column, and it did not work. I don't. Let's see. 1675. 1475. So I want you guys to try it out. You're doing the group 2. 293. After you insert them all in, let's pause and then we can do the next step together. Okay, entered in all my numbers. So now next step is push menu. Go down to statistics. over 2 stat calculations, 1 variable statistics. Number of lists is 1 because I only have 1 list of numbers. And I put everything in the first column, so I'm going to leave my list as the first column, push enter, and then I'm going to have to scroll up till I see my numbers. Okay, I see my mean is 1603.
Wait, what do you do when you're done plugging everything in?
Menu, statistics, stat calculations, 1 variable, enter, enter. Surprise.
Wait, one variable?
You don't have to change anything. You just go.
Yeah.
Just click.
Because I'm not, if you're going to take statistics next year, Ms. Co will teach you all the other statistic calculations. I'm just really trying to give you like a, kind of like a little taste. Here we go. Just
Is Miss Code gonna teach you that?
for AP stats and regular stats.
She's on that like subsets and good luck everybody taking that class.
I'm excited.
Just like we're late always to everything, you realize it? Physics.
I know.
She's in everything.
I'm extra.
You're never
Because my grades
in a good
aren't,
way.
no, my grades aren't that good, so.
What's up for it?
Why don't you do like better?
What is the standard deviation you found for yours?
About 54.61.
6-1. Sweet. So let's go and write the standard deviation. All right, so standard deviation. So the one on the left that I did, it was 100.25, and the standard deviation that you did with group 2, you found was 54.61. Okay, so now which one had the higher variation?
Yours. Group 1.
Yeah, group 1 had the higher. Definitely was higher. Not only was the range bigger, but the standard deviation. The numbers tended to be spread out more. Okay, so where would this come into play? Where would this actually be useful, knowing where something varies more?
Like let's say that's a school out of another school, like which school did better on?
Yeah, like a single test. That would be a good one. The average on group 1 may have been higher, but the numbers were more spread out, so it's not as localized. A big part of standardization. So imagine you buy a case for your phone. You're expecting it to fit, but it depends. Like the machines may not be perfect. Maybe the width will vary just a little bit, and so that's why the cheaper made phone cases, the standard deviation, they don't have as high a standard, so things can be not as close to the preferred. That's why if you buy a cheap case from China, it may not fit your phone the best.
So the standard deviation.
Yeah, the accepted tolerance, the accepted standard deviation is higher versus some of the other things that are more expensive. It's because they have to like be precise. Okay, cool. So we understand this. Frequency distribution or a frequency table. It shows how a data set is partitioned among several categories or classes by listing all the categories along with the number of. Oh my god. Do I need a seating chart? No. Okay, so what I want to do is, it's kind of like I have buckets and I'm trying to sort things. Sometimes I do this when I'm grading papers. And I'll be like, okay, just to give me an idea of how people are doing, I'll sort it by like, did anyone between a 70 and a 79 here, between an 80 and 89 here, and like 90 and above. So that way I kind of get a gist of how people are doing. This is especially true in my old school I taught at when I had like 20 some people in a single class. And then I was grading like over 100 tests at once, and I was like, okay, there's a lot of data, so I just kind of like sort it.
You write everyone's grades down.
Well, Ms. Rotter does. I don't have time like that.
She keeps it?
What?
She keeps it for herself?
Well, like, she's always interested in, like, how people do on her tests and standard deviation, and, like, she...
Wait, homework then?
Huh?
Homework is?
I don't think so. Mostly tests. I look at the online, and I can see the standard deviation online. I can see the bell curve and see if normally what happens is, like, there's two distinct groups. There's people who do, like, highs in 80, and then there's people who do like 60s. That's mostly what's been happening for every test in pre-cal. It's bimodal because there's two modes. There's literally two groups of people. So, all right. So the winning scores for the first 42 Super Bowls are shown below. So let's make a distribution table. Meaning, okay, well, what percent? How many times did the winning score, how many times is it less than 20? How many times is it between 20 and 30? So what we're trying to do is determine the range of data. Okay, what was the lowest value? What was the highest value? And then I want to sort them, but I want to be equal length categories. So I don't want it to be like, oh, everything from 5 to 7 here, and then scores from 8 to 20 here, and then 20 to 23, right? Like, it has to be equal spacing. Does that make sense when I say spacing? All right. You look like you're falling asleep. Wish I could have like a water gun.
That's right there.
No. No, I'm good. All right. So the class boundaries are numbers used to separate classes, but without the gaps created by class limits. So here, let's take an example of maybe the winning score between 10 and 19. So I go highlight all the numbers that are between 10 and 19. So something I notice is it's a lot of the first scores were really small. Yeah, I'm looking for it. Oh, here. So you notice how it was a lot of the early Super Bowls, not necessarily the later ones?
Are these real?
Yeah. First 42. Took this example from the book. So there's 5 tallies. So the frequency, the number of times the scores occurred between 10 and 19 were 5 times. So that's how many times it happened, was frequency. Relative frequency is like, okay, what percent is that? Is that a lot? Is that not? So it kind of gives us context. We're like, is that actually most of the scores? No, it's not. 5 out of the total, which is 42, is about 12%. That's not a lot. So a lot of the times the winning team's going to score more than that. If I would go and do 30 to 39, this is a good one. 30 to 39. Just go highlight. 30 to 39. How many of those occurred? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times. Did I miss one?
No.
Okay. I think it's off a little bit, so it should be 14, not 15. But that's 36% of the time. A third of the time, the winning score is going to be between 30 and 39. I think they miscounted because 20 to 29 should be 17, and 30 to 39 should be 14. It's all right. All right, so the class boundaries are the numbers used to separate classes. And the midpoints are what are exactly in the middle of my 2 boundaries. All right, so determine the following. What is the class width? 10 to 19 is how many numbers? 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It's 10. Each class width is 10. It's literally 10 numbers. 10 numbers, 10 numbers. The lower classes, let's see, what are the lower limits of the classes? 10, 20, 30, 40, and 50. And the upper class limits?
Wait, I'm confused. Yeah, I'm confused.
Okay, well, how big? Huh? So the class is like the category. So here, these are the classes. These are the categories. These are the spacings.
So then the 10 to 6.
What?
So why is the the class width is like
The
how
class
many
width,
numbers? So
how
like
many
10 to
numbers are in
19.
each one?
Okay. So it's by tens?
Yeah. Yep. And the lower class means the lower bound. What? I literally just counted out for you. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Just 10 numbers. 0 to 9 are 10 digits. Because you go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0 is the 10th digit. 0 is the 10th number. Yeah, because I'm going from, 6, 7, 8, 9. Okay, and now if you do 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, is 10 numbers. Yeah. Literally each class width is 10. The lower class limits are literally the first numbers, and the higher class limits are the higher numbers of each class. The class boundaries. Okay, so how do I know when I'm going from one class to another? So here, football scores, you can't really have half of a point. But at what point am I going from the first class to the next? At what's the tipping point?
Like, is it saying like?
So
The
what
number or
what number is like the dividing? Okay, so everything, like when it tips over. Okay, here's a better idea. Let's say you're at an 88 or 89.4% and you're trying to get an A.
That was the 0.5.
The 0.5, because I don't have to round, but I do. Here, 19.5 is the boundary. Once you hit 19.5, you go to the 20 to 29. If you're at 19.4, you stay in the 10 to 19.
So the boundaries are 19.5, 29.5.
Yep. And the class midpoints, meaning what's halfway between 10 and 19?
No 6 is allowed. It's 9.5.
Well, I mean that would be the end of the class. So the class midpoints, if you add 10 plus 19, you get 14.5. The class midpoint is the value in the middle of the class and can be found by adding the lower class limit to the upper class limit and dividing the sum by 2. 14.5, 24.5, 34.5, 44.5, and 54.5. So you might be asking, where do these even come into play? Comes with histograms. So you guys know these as bar graphs. We can literally use a frequency table to draw a bar graph. So a histogram is a graph consisting of bars of equal width drawn adjacent to each other without gaps. The horizontal scale represents the classes of quantitative data, literally the numbers. So here I'm interested in the scores from the Super Bowl. And the vertical represents the frequency, how many times it occurs. So notice these are our categories, our classes. So frequency is the number of data values in a class versus relative frequency tells you how often it will occur. It's literally a percentage. And if you add all of these frequencies together, you should get 100%. Frequency is number of data values in a class, literally how many times it happens. And the relative frequency is the percentage from the total. It gives you context if this is a high or low frequency for the data we're looking at. Yeah. So for instance, if I was doing a bar graph, a histogram of SAT scores. So the SAT scores where it's like a perfect score, those are not high frequency. So it'd be a very low frequency because it doesn't happen that often compared to how many people actually take the test. All right, quartiles. So think about it. How many quarters make up a dollar? 4. So quarters literally take all your data and divide it into fourths. In a set of data, the quartiles are the value that divide the data into 4 equal parts. So we have the min on the left side and we have the max on the right side. The median is literally halfway between your min and your max. Q1 is the lower quartile. It's the median of the lower half of the set. So it's the median between the min and the median of the whole number. It's like your middle of your lower half. Q3 is the middle of your upper half. And it divides your data into 4 equal parts. Equal parts being 25% of your data are between each quarter. All right, so a lot of this is like, oh, hey, that way you can come back later and you're doing your homework. You're like, wait, what? So Q1, the first quartile separates the bottom 25% of sorted values from the top 75%. Q2, second quartile, same as median, separates the bottom 50% of sorted values from the top 50, so it's exactly half. That's average. If you've ever seen a bell curve, ideally, like this is 70, this is 100, you want your bell curve to look something like this. So most people are at the center. A lot of the people are like super, super close, and you don't have too many outliers. That's a bell curve. That's a lot of times what you want to see when you're grading a test. All right, so use the data set for the Super Bowl scores shown above to determine Q1, Q2, Q3. So I want you to do, insert all 42 numbers and find Q1, Q2, Q3. But wait, pause. Remember how if we keep scrolling down, it tells us Q1, Q2 and Q3. So if I would make this a little wider, you would see that besides median, it says Q2.
But here's different ones.
What do you mean? This isn't for the Super Bowl. I'm just showing you. Literally when you do menu, statistics, stat calculations, one variable, enter, it will tell you all 5. So all these 5 that I'm showing you on the screen are the 5 number summary. Shows you the min value, the first quartile, the median, the third quartile, and the max.
So we
Huh?
have to plug all.
So I want you to plug it in, and so this is your practice. I want you to plug it in. Find the 3 square. Yeah, 42. 42 numbers is fine. Build a bridge and get over it. Okay. Said that in my observation the other day. That was great.
If you do it all of it, then why is it do it all?
Well, the cool thing is you can go back, change the number that you messed up.
I lost the game.
The best way I ever won the game, I put it on the semester 1 final for my seniors in AP Calc
Oh, I heard
BC.
about that.
And
Daniel Schulman, right?
Yeah, he got it because it was the bonus. Like, stand up and say, Miss O'Brien won the game, and I'll give you an extra point. He did. It was great.
Wait, what?
You lost
Did
the game.
only one person do it?
Yeah. Yep, only one. First person.
The first person to stand up because it was on the back of the test. Right?
Yep. So, okay. So here I was showing you Q1, Q2, Q3. It's the same thing. Guess what? It's the same data points. Now you're just looking and doing the 5 number summary.
How?
I had 41, so I did it wrong. And I already entered.
How is that even possible? Oh.
I got the same numbers. And
So these are the numbers. And then we're going to spend the last 5 minutes, because box and whisker plots are literally like 6 minutes, not even. Super chill. And then when I have you guys in class tomorrow, we'll work on, like,
number 8.
no, we did it. It's literally the same problem. Here, the middle 3 are what this is. I don't know why I gave you so much space for this. Menu, statistics, stat calculations, one variable, statistics, enter. And then you're gonna have to scroll up. You have to scroll all the way to the top because it gives you like maybe 12 calculations, and at the bottom you are what?
Will you scroll up a little?
I
Where?
see her.
What the? Oh no, where you want me? Where you want me? Here?
Yeah.
Okay. Give you 30 more seconds of this, and then we
Can
shall.
I get that?
No, I put it up there for a reason.
No, please. I really want one.
I have one
I
more.
already have 3. One.
They're all over school.
This is the second one I've ever seen.
What?
I think I told Yoni to put it up there and he did.
Is it one of the plastic babies?
What? No, I was waiting for people to recognize that it was
Okay,
him.
I found it. Can I take it now?
No.
I'm gonna come back and take it later.
Wait, tomorrow.
I'm gonna take it. You're gonna take it.
I was just joking. You can't take it tomorrow either.
Uh,
No.
Yeah, you're gonna break the clock.
I can stand on a chair. I'm
Okay.
gonna ask Abby to do it.
All right, so we're ready for the next part, and this is the last new material.
Ever?
Yeah.
Freedom! I was about to say like forever, but we're gonna next.
Are you taking calculus?
Hmm?
Are you taking calculus? Okay.
She's like, damn it.
At least okay.
Say it.
No. I just don't like when people roll their eyes at me.
Susan, what?
When people roll their eyes at
I
me.
don't roll my. I don't know what thing I roll my eyes. I don't notice it. I'm sorry. I don't need it.
Okay. Took months for me to realize it.
Yeah, you do it.
Took me months for me to realize that.
Did I roll my eyes?
That you don't mean
You used
to.
to do it a lot, but you don't do it anymore. Yeah.
I literally.
You guys don't do it as much. They used to.
maturity.
No,
Me?
You used to do it a lot.
All right, guys.
The only reason I know is because my tutor told me that I do, but I never noticed it before. Like, no one's ever told me. It's rude.
Box plot, also called box and whisker diagram. A graph of a data set that consists of a line extending from the minimum value to the maximum value, and the box with lines drawn at the first quartile, the median, and the third quartile. Okay, so how the hell do I do this? First, find the 5-number summary. Oh my god, guess what? That's what we just learned how to do. You go through standard deviation, like the little stat calculation on your calculator. It tells you your 5 things. Then you construct a scale with values that include min, max values. Construct the box from Q1 to Q3. Draw a line at median value, and draw lines going out. Okay. So we're going to do this example. First, let's find our values. Q1, Q2, min, max. Guess what? Ohio State University, this is my maximum value. And this is my min value. Are you okay? Cool. Because we're going to do the stat plot tomorrow, the worksheet I'm going to hand out. So which one's in the exact middle?
Let's see.
Bowling Green.
Yeah, I would say both. No, I would say
Which one?
both Bowling
Here,
Green and University
one.
of Toledo.
Yeah. No, I think Bowling Green.
This one? Bowling Green?
Yeah.
Wait, hold on. 1, 2, 3, 4.
Yeah, you're right.
5, 5. Hey, Bowling Green. Okay, Bowling Green's the median.
There's Shawnee State University.
Bowling Green, median. All right, so halfway between, let's see, here. Kent State, this is Q3. Halfway between here. Cleveland, Q1. Now guess what we're going to do?
We're going to plug it in.
Okay, step 1, find 5-number summary. Did it. Step 2, construct a scale.
I didn't see it.
10, 20, 30, 40, 50, 60. This is 60K, 40K, 20K. So this is in terms of 1,000. Okay, constructed a scale value. Now let's plot. My min is 2,000, so that's about right here. Q1's at 15,000, so that's there. Q2's at 18, so that's there. Q3 is at 22, so that's there. And my max is at 52, which is out here. And I'm supposed to construct a box from Q1 to Q3. So I'm drawing, you'd have a box that puts those there. This is from middle school math. Draw a line straight down with median. And then extend your whiskers. Box. And here's your whiskers. Haha, okay. Yeah, and that's actually it. There's no more examples. This is how to create histograms. I don't care about creating histograms on your calculator because we're going to do it in person. And we're done.